It's a really good book.
I know, but tell me what is it's a theory of what?
It's called they still have it. It's called Sphereland, and it describes the theory of relativity, distance.
Sphereland.
By using geometric shapes. Okay, so basically it says, like, say you were in a linear universe, so there's just all you could live is along a line. That's it. So there's no up or down or out or in. It was not three-dimensional. It was only one-dimensional universe. Okay? And so you would be. How would a dot look to you in that universe?
I don't know.
Well, you can only see ahead of you and in back of you. So if there was a dot there, it would kind of be, you'd see a dot, right? Yes?
Okay.
Okay. So now, if you, let's say, I'm trying to think how we do this. So now you have a very limited view of the universe, because your universe is just this way and that way. It's a line. Okay, now let's say you are in a plane universe, a planar universe, meaning you're on a plane. It's not three dimensional, it's only two dimensional. So there's an X and a Y. Okay.
He's drawing a square.
Right. You can go anywhere along that plane, but you can't go out of it, and you can't go below it, because there is no out of it or below it. You only exist in that plane. And now, say a sphere comes into your universe. Okay?
I don't know what a sphere is. What if I don't know?
It's
not
a
a
three-dimensional
point
circle. That's a three-dimensional circle.
Okay, 3D circle.
It's a sphere. It's a ball.
A ball.
It's a ball.
It's coming to my life.
So a ball.
I'm so happy.
Here's a ball. Let me see how many balls are out here I can show you. I can do this with. So here's your flat universe.
Oh, wait.
And okay, right? So there's no up, there's no down, there's only this way, that way. You can only live and exist on this plane. So as a ball passes through your universe, it's going to start off as a dot, and then it's going to expand as a circle, and then it's going to shrink back down to a dot as it passes through your universe.
Why?
Because you can't see the whole ball. All you can see is the cross section of the ball as it passes through your universe.
So it's not a dot, it's a ball. The whole time it's been a ball.
It's a ball, but you're not going to know it's a ball. You're not going to see a ball because a ball doesn't exist in your universe. Only circles exist in your universe.
Okay, got it.
So it's going to look like a tiny little dot, and it's going to expand as a circle. And when it gets to the diameter, it's going to passes through the diameter. It's going to start shrinking back down into a little dot. I wish I could show you a ball.
I get it.
Someplace.
No, I understand.
Now, think of, so you get that, right?
Uh-huh.
What if a line passes through your universe? What's that going to look like?
Wait, why would I have a line and a ball passing through? That sounds like a baseball and a baseball bat. That sounds like it would be in a man's
So
universe. In my universe, there might be shoes or clothes.
Those are too difficult to describe. Okay, let's think of a cross-section of a shoe passing through your universe.
Got it.
What would you see?
Well, it depends on which part of the shoe.
Exactly. Okay. Okay, good. Okay, we can with this with shoes. Okay. So that
could be like, anyway.
Okay, so now we have a three-dimensional universe, right? And so what would it look like if a fourth-dimensional creature passed through a three-dimensional universe?
Don't know what that means.
Well, here we have a two-dimensional universe, and a ball is a three-dimensional creature, and it passes through your universe.
We got it, but what is a four-dimensional universe?
Four-dimensional
ball.
You could say X, Y, Z, and maybe time.
But can you explain it to me?
There's infinite number of dimensions.
Okay.
Mathematically.
Okay, so how does that, like... how can I imagine?
That's the thing. How can you imagine? How could you picture this thing? What would it be?
I don't know.
Right.
Probably be the amazing pair of shoes. Or a really cool purse or
So it was
jacket.
a really awesome book that just kind of talked about how what does multiple universes look like, and it relates it to to things that we can picture, which is a line or a plane or our 3 dimension. So let's say, let me think. Yeah, that's best. That's really good to do. So what would a 5th dimensional creature look like if it passed through a
Probably an alien.
3-dimensional universe? Because we only know 3 dimensions. Well, we know 4 dimensions, but we only really usually there's other dimensions too. You can put other dimensions, but anyway. So mostly we consider ourselves a 3-dimensional creature. So it's a really good book anyway. Isn't that cool?
So cool.
Well, how do we get on that though?
Yawning.
How did we get on that? No. It's a really good book. I just can't remember why we started talking about this.
I don't know. You wanted to talk about aliens and the 5th dimension.
No, I didn't.
I don't know what you wanted to talk about.
We somehow got into the theory of relativity.
You said you read a cool book.
No. What was it? It was related to something we were talking about.
Was it?
We're doing log books.
Oh, maybe it was something to do with the log book. Oh, lines. Because you were mad. You're not mad. You were disappointed. He was disappointed that his logbook
is crooked.
It's crooked. The lines, you see?
Oh, I know. I said I need lines.
Yes, and I said you could take a pencil and draw lines and later erase them.
And somehow it made me think of Sphereland book, and then the theory of relativity, or so anyway, yeah.
The theory of shoes.
So what would it look like if a 5-dimensional pair, a being with 5-dimensional shoes passed through our universe?
That'd be so cool. I would have to recreate the shoes and wear them every day. I don't know
what would they look like?
I don't know yet. I'm going to dream about it tonight.
So...
And they're probably not ones that I could wear on the boat.
If the 4th dimension is time is actually a dimension, it's not constant. So time, as you approach the speed of light, time, I forget now. As you approach the speed of light, time, I think, slows down. Where as you get to the speed of light, there is no time. It's infinite.
So you're really close to the light.
So think of like spaceship travel. So as theoretically as if we ever want to get any place in this galaxy, solar system, galaxy, then we're gonna have to really figure out a way to move really, really fast, close to the speed of light. Not quite get there, but I mean like really, really fast. So the closer you travel to the speed of light, you age slower, I believe.
Oh, that's where I want to go. I do. I mean, I'm not liking how my neck is looking at this.
Is that how that works? Yeah, so like if you put a baby on Earth, and then you stuck a baby in a spaceship, you're kind of mean now.
Child abuse. What do you mean trying to witness child abuse?
This is what you do in physics problems. You stick a baby on Earth, and you stick a baby in a spaceship, and you send the spaceship off close to the speed of light for, I don't know, a year.
That is child abuse.
Okay. And then you bring them back together. The baby on Earth is going to be a year old, but the baby on the spaceship is going to be, let's see, it's going to be an old man or one of the two. Actually.
In a year?
Yeah, I think that's what it is, something like that. Yep. Yeah.
So that's the one in the spaceship goes slower?
Spaceship goes closer to the speed of light.
Which means?
Which is, the speed of light is like really, 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 really fast. Light. like light, the speed of light. Light has a distance c. 3 times 10 to the 8th meters per second squared. That's the acceleration.
This is why we should
3
call
times
this
10 to the meters.
Hello
3 times
Talk,
10 to the 8
because
meters per second.
you know,
I think gravity is 9.8 meters per second squared.
you get so
The acceleration of gravity.
so excited about all these formulas and everything
I used
when
to do this stuff all the
when
time.
you have your head on your pillow. When we're like in our PJs,
So I don't know how we got in that one either.
unwinding,
I get all excited
and
for
you
some
get
reason.
all
All because of the wine.
and the excitement that the things he's excited about. Not me. Theory of relativity. That's what he's excited about.
It was really neat. Oh, sorry. I don't know. I don't know how I got on that though. Oh well. I'm tired now.
Overthought that
Yeah, I
theory.
didn't think too much. Yeah, I'm tired.
All right.
I don't think I got it right though either. But I still think as you approach the speed of light, time turns to infinity.
All right. Well, you think about that. I'm gonna go check the laundry so you have dry shoes tomorrow to wear on the boat.
I have to look that up. Whether the baby will turn an old man on the earth. I think what it is. Time speeds up. Yeah, that's right. If time speeds up, then the baby at the year would be like an old man. Like could be 100 years old. Versus the baby on Earth would be still a baby.
Be a day old.
Yeah, a year old.
So I'm just gonna stay on Earth.
Huh?
I'm not gonna go to the speed of light because then I'll come back all wrinkly and gray hair.
Yeah, and you have to compare them. Like physicists do that. It's important to know what your system is. Like if you describe like the Doppler effect. You know how if you hear a car coming at you, it's like it changes it's not just a constant whir. It's like a
You do that really well.
Thank you. That's the Doppler effect.
Oh.
What's happening is, as the car is approaching you, let's see, it's squishing the sound waves together, and so you hear that higher pitch, and as it passes you, they stretch back out again. So the frequency goes down like like race cars, like Indianapolis 500. You hear the Indianapolis. Right.
No, it's just because the car is closer to you and farther away that you heard it a different sound, different.
It's a different frequency though. It's not a different sound. It's a different frequency. It's not the same thing as a car like. That's the same frequency. It goes. So it's the Doppler effect, baby.
The Doppler effect. Okay.
Yeah, that's what they used to like. Cops used to get speeders to Doppler effect with light though. Something called red shift and blue shift.
You are full of information.
I know I
tonight.
am. Like useless stuff tonight. I don't know why. This stuff is just popping in my head.
This is getting to be a very long
Yeah.
video.
Oh.
14 minutes
Oh wow,
long.
that's really long. Okay, bye.